monomial is a one term and a polynomial is many terms. We've been working with a lot of monomials, and it tells us to multiply a monomial and a polynomial, simply distribute, which tells me to multiply, the monomial to the polynomial. And we just want to remember our product rule. When the base is the same, they can multiply across, you add your exponents. So here's a good example with some numbers. Your base is the same, your base is the x. You're multiplying across, so you're going to add the 2 plus 5, and that will give you the 7. So let's go ahead and check out our first two examples. So for example 1, we have x on the outside. That's going to be our monomial. Then inside my parentheses, that's 2 terms. That's a binomial. We're going to multiply the x times the x, and then the x times the 4. Now I know that technically the exponent on those x's is a 1. So if the base is the same and you multiply across, you add your exponents, which will give me x squared. Then we know that positive 4 times x will give me a positive 4x. I can't combine these two. They don't have the same variables, so I'm done. Not too difficult. First example done. Second example is a better example because it has numbers, variables, and an exponent other than 1. So my general rule is you multiply your numbers, you add your exponents. I see that this guy has a negative symbol, but not a 1. I'm going to put a 1 in there just to remind ourselves that that's a negative 1. Here's my monomial, and I'm going to distribute. So I'm going to multiply this by each one of these terms. If I multiply by 3 terms, I should have 3 terms at the end. So let's start with our numbers. 5 times 3 would give me 15. Next, let's look at our variables. Our bases are the same. We're multiplying across, so let's add our exponents, giving us m to the 5th power. All right, that guy's done. Let's move on to our next term. 5 times negative 1 gives me negative 5. This is technically a power of 1, so I have 3 m's here and 1 here, which gives me m to the 4th power. All right, that guy's done. Let's look at our numbers. 5 times negative 7 will give me negative 35. Now, just because I don't have anything on the end of the 7, doesn't mean that I can drop what's on the 5, so I have to still bring down my m cubed. None of these have the same variable and exponent. I can't combine them, so that one's done. So not too bad. Right below you try, I want you to write a little note here. Multiply your numbers, add your exponents. Just having those cute little hints on the side help me to look at my notes, see that hint, and know exactly what to do. We'll start off pretty easy, but then we'll work our way through and get to some more difficult ones. Notice that they want our final answers to be in standard form. And that just means that they want your highest exponent first and in alphabetical order. So let's try number 1. We have k as our monomial. We're going to multiply it by both things inside of the parentheses. K times k would give me k squared. K times negative 9 would give me negative 9k. Let's look at number 2. We have a 9 and an a in our monomial. Let's distribute that. Technically, there's a 1 in front of that a, so 9 times 1 is 9. And then I have a times a, and I know that a times a is a squared. Next, I'm going to bring down my plus sign, 9a times 1. Anything times 1 is itself, so it's 9a. Now, I cannot combine these because they're not like terms. In order to combine them, I'd have to have the same variable and exponent part. So, look at our next 2 examples. Here's our monomial. So here I'm going to be multiplying negative 6 times 1, which would give me negative 6. Then I have p to the first here times p to the 4th. When your base is the same and you multiply across, you add your exponents. Now I have a negative times a negative, and I know that gives me a positive. 6 times 8 would give me 48, and I don't want to forget the p on the end. Take a second there. Any questions so far? All right, let's look at number 4. There's our monomial. Let's multiply our numbers and add our exponents. So we have 3 times negative 2, which would give me negative 6. C to the 5th times c, when your base is the same and you multiply across, you add your exponents. So I'd have c to the 6th power. Next I have 3 times negative 5, which would give me negative 15. And then I'm going to keep my ending or my last name there, c to the 5th. So far so good. Take a second, make sure you have all that copied down, then we're going to move on to the next section. Perfect, right there. Thank you. All right, we're on number 5. As you can tell, it's going to get a little bit harder, but these are pretty much the same. Once we add a couple of exponents and variables, then it gets a little tricky, but as long as you follow the same rule, you'll be good to go. Let's look at number 5. We're going to take our monomial on the outside. We're going to multiply by everything inside. We're distributing. Multiply your numbers, add your exponents. So we have negative 4 times 2, which will give me negative 8. G squared times g would give me g to the 3rd power. We're writing down, well, negative 4 times 7 will give me negative 28. And I'm going to keep that ending of g squared. Everything looks to be in standard form so far. Let's look at number 6. We know that the exponent on that x is technically a 1. I'm going to distribute that x to everything inside my parentheses. We've got 3 terms in there. That's a trinomial. So x times x squared would give me x to the 3rd. X times negative x would give me negative x squared. X times 3 would give me positive 3x. Is it starting to make sense? Multiply your numbers, add your exponents. Let's look at this one. Negative 3n is your monomial. Let's multiply by all 3 of your terms. It's trinomial. 1, 2, 3. So we have negative 3 times technically a 1, which would give me negative 3. Then I have n times n squared, which would give me n to the 3rd. Next term, negative 3 times negative 2, which would give me a positive 6. N times n would give me n squared. Then we have negative 3 times 8, which would give me negative 24. There's no ending there, but we still have the n here, so I'm going to bring that guy down. We can't combine any of these because they are not like terms. They would have to have the same variable and exponent part. All right, let's look at number 8. Here's our monomial. We're distributing all 3. Let's see what we got. Multiply your numbers, add your exponents. Negative 2 times 6 is negative 12. I have x to the 4th times x squared. When the base is the same and you multiply across, you add your exponents. Let's look at our numbers. Negative times a negative gives me a positive, and 12 times 2 is 24. I have x to the 4th here, and just an x there. Together, I have x to the 5th. Negative 2 times 18 is negative 36. I don't have an ending on the 18, but I still have the x to the 4th, so you got to bring that down. We're doing a great job so far. We're going to change it up just a little bit here. We're going to look at multiple variables. So here's my monomial here. And I'm just going to do myself a favor. I'm going to put a 1 in over here so that when I distribute, I remember to add. So let's look, there's no numbers, so we're not concerned about that. So we're just adding our exponents because we're multiplying across. So p squared times p to the 5th would give me p to the 7th when you add those. Q to the 3rd times q squared would give me q to the 5th when you add those together. Let's bring down our subtraction sign. We have p squared times p, which I know is giving p to the 3rd. That little 1 exponent is helping to remind me of that. And q to the third times q would give me q to the fourth power. Let's add in a number and multiple variables. I'm going to throw an exponent of 1 on both of those guys. And on these two, just to remind myself. We need to distribute to all three of those terms. Let's start with our numbers and add our exponents. This is technically a 1, so 3 times 1 is 3. X times x squared would give me x to the third. Since I have nothing else with the y, I'll just bring down the y. 3 times 1 again is 3. Add x times x, which will give me x squared. Y times y, which will give me y squared. Then off to the end. 3 times 1 again is going to give me that 30. There's no x over here, so I'm just going to bring down the x from the monomial. And then y times y squared will give me y to the third power. How are we feeling so far? Is it making sense? Multiply your numbers, add your exponents. All right, wonderful. Take a second, make sure you have all that copied down. And we'll look at the rest on this page. I think we have 11 through 14. And then we'll add a little bit of addition and subtraction into that as well. Thank you. All right. Number 11. We're not doing anything different here, guys. The only thing I'll say is if it helps you, put in your 1 so that you don't forget to add that exponent. We're going to be distributing. Let's multiply our numbers and add our exponents. Does anybody want to try it out on your own? All right. So let's go ahead and get started. 5 times negative 2 would give me negative 10. R squared times r squared. All together, when you add those exponents, you're going to get r to the fourth power. There's no s over here, but there's an s squared there, so I'll bring it down. Next, 5 times positive 3 would give me positive 15. I have r squared times r, which would give me r to the third. S squared times s, which gives me s cubed. All right, almost done. 5 times negative 4 is negative 20. I don't have an r over here, so I'm just going to bring down my r squared. But s squared times s squared will give me s to the fourth. Number 12. 3 times 4 gives me 12. A times a squared gives me a to the third, and then we'll just bring down our base since there's nothing to multiply by. 3 times negative 7 is negative 21. I'll bring down my a. B times b cubed will give me b to the fourth. Alrighty. Next one. Negative 7 times 9 is negative 63. Then we have c to the third times c squared. If you have the same base and you multiply across, you add your exponents. D squared times d squared is d to the fourth. Now you notice we have a negative times a negative, which would give me a positive 28. 7 times 4. Then we have c to the third times c, which would give me c to the fourth. D squared times d to the fifth would give me d to the seventh. One more in this section. All right. Multiply these. We have 10 times negative 2, which is negative 20. M to the fourth times m gives me m to the fifth. N times n to the third gives me n to the fourth. n times positive 3 would give me positive 30. We're going to just bring down the m to the fourth, and then n times n gives me n squared